Okay, guys, let's talk about the basic tree terminologies. The terminologies that you should remember, the basic concepts that you should remember when you talk about data structures. Okay, when you particularly talk about non-linear data structures, especially trees. Okay, okay. The first terminology is nodes and edges. Okay, I think I've explained this to you in the previous video. A tree may look like this: A, B, C. This may again have D, E. This may have E, sorry, F, G, H. So this may be a tree. So the nodes in the tree are A, B, C, D, F, G, H, and the edges are, this is an H, this is an H, this is an H. Okay. So I have how many edges? 1, 2, 3, 4, 5, 6, 7. I have 7 edges here. Okay, I have 7 edges. Okay, and there is a relation. How many nodes are there? Uh, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 nodes. So I have 8 nodes and 7 edges. So if I have generally if I have n nodes, I'll be having n minus 1 edges. So this is a very good, very important relation. Okay. So if you have 5 nodes, you will be having 4 edges. Let's take an example with 3 nodes. If you have 3 nodes, you will be having 2 edges definitely. Okay. Let me say I'll be having 3 nodes here. You can see we got 2 edges. So node 1, node 2, node 3, of course. But we got 2 edges here, right? So edge 1 and edge 2, right? So that's all about nodes and edges. Okay. The next terminology is, I think, second terminology, right? The root of the tree. Okay, root of the tree. Root is basically the first node of the tree. Okay, so root is basically the first node. Okay, so I'll write it here. First node of the tree, right? First node of the tree. Let's say my tree looks like this. I think I have to take another color. This will be fine. Let's say my tree look like this. I'll be having A here, A, B, C, D. Okay, so this is my tree. Okay, I can have like this, right? So this A is called the root node. Okay, because this is the starting point of the tree where I can access the whole tree, right? So this is the root node of the any tree. And one important point is which I wanted to tell here is there should be only one root for a tree. Okay, only one root. Okay, you cannot have more than one root for a particular tree. Maybe any tree. We have a different types of tree, guys. I'll be telling you about that. But that should be only one root. Okay, right. Super. So the next concept is parent. Okay, parent. What do you mean by parent? Okay, let me take a tree for an example. A, B, C, D, E, F, G. You can see. Okay, let me also explain the concept of child here. So parent, child, right, and siblings. Some interesting concepts, right? Parent, child, and siblings. Okay, and it's pretty straightforward. You could understand from the word itself. So you can see if you want to search for parents here, you can see that the B node is the parent of D and E. So the first inference I could write from this tree is B is the parent of D and E, because only after B you got D and E, and tree follows hierarchy. Again, I want to insist that here. So only after B you got D and E. So B is the parent of D and E. Other words, D and E are children of B. Both are correct, right? D and E are children of B. Both are correct. And also D and E are siblings. Why? Because they belong to the same parent B. If both the children belong to the same parent, then they are called as siblings, right? Brothers and sisters or whatever. So they belong to parent B. So those are called as siblings. I'll ask you a question, whether E and F are siblings? No, definitely not, right? Because they don't belong to the same parent. E is the child of B, F is the child of C, right? So uh, E and F are not children. Okay, I mean are not siblings, right? Let me erase this off. Oh, no problem. I'll write. Okay, I had a B here, right? Uh, what are the other references I could make? Again, C is the parent of F and G. I hope it is clear to you. And F and G are children of C. Okay, and again F and G are siblings. Those are the three inferences. Again, you can also say that A is the parent of B and C, right? You can also say that. And B and C are children of A, and B and C are siblings, definitely, right? So that's how a tree works: parent, child, and siblings, right? And the fourth terminology where I wish to explain is leaf. This you can understand in a biological way, guys. A leaf is something which after that you don't have any continuation, right? If you consider a tree like this, right? A leaf is something after that you don't have any continuation, right? Okay, so that's the end of the tree. Abstractly, that is the end of the tree. So you can say that nodes which don't have any children are called as leaves. Nodes which don't have any children. Okay, I'll give you an example. This is A, this is B, this is C, D, E, F, G, right? This is an example. And here, what are the leaves of this tree means? The leaves are D, E, F, G. So the leaves are D, E, F, G because they don't have any children. They don't have any. Those are the last nodes. They are also called as terminal nodes. Okay, they don't have any children, so they are also called as terminal nodes. They have another name also called as external nodes. Okay, external nodes, right? And that's the fourth concept. And fifth one is a contrasting one to the previous concept. It is called as internal node. Okay, internal node, it is just opposite to leaves, guys. Just opposite to leaves. What we have seen a while ago. Just opposite to leaf, the internal nodes. The nodes which have children, okay. Leaves are something that they don't have children, right? We have just now seen D, E, F, G, they don't have children, that's why they are called as leaves. Whereas internal nodes are something which have children, okay, which have children, right? And yeah, let me give you an example quickly. A, B, C, D, E, F, G. So the internal nodes here are A, B, and C. Of course, A is the root node, but that's the internal node also, right? So A, B, C are the internal nodes here, right? Okay, because they have children. They have children. Oh, sorry, they have children. Okay, they are not children. They have children. Yeah, B has D and E, C has F and G. So A, B, C are called as internal nodes. Okay, or non-leaves. Okay, both are correct, right? Non-leaves. Okay, non-leaves, right? The next one is degree, which is very important, very important, guys. Okay, you have this concept in graph also, degree. Okay, degree is nothing but the total number of children that a node has. The number, it's a number, guys. Okay, it's a number, it's a measurement, total number of children a node has. Okay, a total number of children a node has. Okay, let me explain this with an example. Say A, B, C, D, E, F, G, H. Okay, what is the degree of A? If somebody asks me. Okay, let me put a table so that I'll write degree for each and every node here, right? You can write degree for each and every node, guys. So this is node and this is the degree value, right? So first is for how much it's the degree for A. Okay, so node A has two children, right? Two main children. That's the okay. So you have to consider only the children which is directly connected to A, right? So in that sense, A has only two children. So A has two. B has again B has two children only. So B has two. Okay, B has two. Sorry, right? And D and E doesn't have anything. So D comma E I could say 0. FGH also they doesn't have anything, so I could say 0 because DE FGH are all leaves. Okay, leaves won't have children. Just now we have seen leaves won't have children. That's why their degree is always 0. And you can also claim in this way. In MCQ questions, they will trick you. They will make some tricks like this. A leaf is something which has degree 0. Okay, leaf is something which has degree 0. Super. And C node has three leaves, right? Three children, right? FGH. So degree of C is 3. Node with the highest degree is C here, right? So that's how degree works. I hope you understood this. And the next terminology is a level, and this is something very important, guys. Level, right? Okay. Seventh terminology. Level is A. Let me take an example. Let's say this is my tree. Okay, you can also have as many number of branches, but let me stick with this short examples. Okay, right. So this is called as level 0. Okay, and this is called as this particular level is called as level 1, which contains B, C. And the last level is called as level 2, which contains D, E, F, G. Okay, level 0 will always contain only the root node. Please remember this. Okay, because we have only one root, right? So level 0 will always have the root node, and level 1, level 2. If you have some more connections, you will be having level 3. So that's how level works. Okay, that's why it's called as level, right? And next one is called is something confusing. Okay, so eighth concept, that is height and depth of the tree. Height and depth. Okay, I've seen people who find hard to understand the difference between these two, right? Okay, I'll give you some simple tricks to remember the difference, right? Height and depth. Okay, depth is something you have to measure downwards, guys. Okay, you have to measure downwards. Height is something should be measured how upwards, and this is the thumb rule. Okay, this is the thumb rule which I wish to remember. Okay, so height should be measured upwards and depth should be measured downwards, right? Let's take a tree and analyze, right? So A, B, C, D, E, F, G, right? Super. Okay, what is the height of C? Somebody asked me what is the height of C. Uh, Before that, let me give you the traditional definition also. Right? Traditional definition is height is length of the node. Height of a node is length of the node from the leaf. Okay, from the leaf. So you have to start from the leaf and you have to go upward till the node. Okay, that's why I told you upward, which means that you have to start from a leaf and you have to go up. That's how you have to measure the height. Okay, whereas depth is downwards, right? So it is the length of the node or length of the branch from the root, because it is measured downwards, right? So you have to start from the root and come back, I mean come down, so that's downwards, that is depth. Okay, so let me measure height and depth for node number C. Okay, for node C you can say I'll write height in this color, okay, and I'll write depth in sky blue, right? Super. So don't get confused. So height of C is, look at the definition, it should be measured from the leaf to that node. Okay, so leaf is where you can consider either G or F, right? So if you consider G, the height is 1 unit. So height of the C node is 1 unit. Okay, because you have only one branch. Number of branch, that's it. Okay, number of branches or number of edges. So 1. Okay, not number of branches, number of edges only. So 1. Okay, and depth of the node is from root we come below, so 1. Depth is also 1, right? Okay, because you have only one branch, so depth is also 1. Sorry. Okay. What is the height of the tree, the whole tree? We have just found the depth and height of the node C, right? But what is the height of the tree? Somebody asked me, depth is very simple. Depth and height measurement is very simple. For depth, I have to start from root node and I have to go up to the last leaf, right? So 1, 2, right? So the depth is 2. Depth is 2, right? And for height, I have to go from below, right? So I have to grow. I have to select a leaf. All the leaves are at the same level. Okay, so you can select any leaf. Okay, so yeah, 1. This is 1 actually. 2, and height is also 2. I am reaching the node root, so height is also 2, right? So that's why you have to measure depth and height. All right. So keep drawing some trees and keep practicing so that you'll be able to understand, right? Okay. Super. 12th concept is path. Path is something very simple. Okay. Oh my God. Let me say H. Yeah, this is I. So let's say I just want to find the path between A and F. Okay. So the path here is A. I have to go up to B and I have to go to D and I have to reach F. That is the path, right? So A to B, B to D, and D to F. That is the path. That's why that's what we call as path. That's it. It's a way between two nodes. Way between any two nodes. Any two nodes, right? So that's all about path. Okay, and you have the concept of subtree. I think that's the last concept which I want to discuss in this video, right? Subtree is very simple, guys. This is a tree, right? If this is a tree, then you can call this one as subtree. Okay, you can call this one as subtree. That's it. I hope I have quickly explained all the basic terminologies which are used in tree. I think this is very important to put down the fundamentals strongly. Thanks a lot, and in next video we'll see a lot.